Hello students, welcome to the question, answers and derivations section of our new video on work, energy and power, which is given as chapter 6 in physics for class 11. As usual, whenever you feel that I am going fast, you pause this video and note down all the important points. I welcome you once again. We'll start this with short answer questions of mark 1. Define conservative and non-conservative forces. Give examples of each. Answer. A conservative force is a force whose work done is independent of the path taken and depends on only the initial and final position. Examples of conservative force are gravitational force and electrostatic force. The non-conservative forces are those where the work done or the kinetic energy depends on other factors such as velocity or path taken by the object. Example of non-conservative forces are forces of friction and viscosity. Question number 2. A light body and a heavy body have the same linear momentum. Which one has greater kinetic energy? Answer. Light body has more kinetic energy as kinetic energy is inversely proportional to m, that is kinetic energy is equal to p square divided by 2m, where p is the momentum and m is mass. And if we take momentum as constant, then ke is inversely proportional to 1 over m. Question 3. The momentum of a body is doubled. What percentage does its kinetic energy change? Answer. Kinetic energy equals p square by 2m, where when p is doubled, kinetic energy becomes 4 times. So percentage increase in kinetic energy is equal to delta Ke by Ke into 100. So delta Ke is 4 Ke minus Ke divided by Ke, that is equal to 3 into 100, 300%. Question number 4. A body is moving along a circular path. How much work is done by the centripetal force? Answer. Work is equal to F into S into cos 90, cos theta, that is 90 degrees in this case, where W is the work, F is the force and S is the displacement. That is equal to 0. Question number 5. Which spring has greater value of spring constant, a hard spring or a delicate spring? Answer. Hard spring has greater value of spring constant. Next question. We will continue with 1 mark question. Question number 6. Two bodies stick together after collision. What type of collision is in between these two bodies? Answer. The collision between these two bodies is perfectly inelastic collision because the two bodies stick together after collision and move with the same velocity. Question number 7. State the two conditions under which a force does no work. Answer. The first condition is displacement is 0 or it is perpendicular to the force. And the second condition is conservative forces moves a body over a closed path. Question number 8. How will the momentum of a body changes if its kinetic energy is doubled? So momentum becomes square root of 2 times. Question number 9. Kinetic energy of a body is increased by 300%. Find the percentage increase in its momentum. So kinetic energy is given by Ke is equal to P square, momentum square by 2m. That is equal to P is equal to, rearranging, P is equal to square root of 2m into capital K. Capital K is the kinetic energy and m is the mass. So increase in kinetic energy is 300% of K, that is 3 into K. Therefore, final kinetic energy Ke is equal to K dash is equal to K plus 3K, that is equal to 4K. And final momentum P dash is equal to square root of 2m into K dash. So here we have to put the K dash value as 4K. Therefore 2m into 4K, that becomes square root of 4 is 2, which we have taken outside, 2 into square root of 2mk. So square root of 2mk is P. Therefore final momentum is 2P. Therefore, the final step is percentage increase in momentum is equal to P dash minus P over P into 100. Therefore, P dash is 2P, 2P minus P is P, P over P gets cancelled, it is into 100, 100. Therefore, 100% increase. We will continue by answering 1 mark questions. Question number 10. A light and a heavy body have the same kinetic energy. Which of the two have more momentum and why? Answer. The heavier body will have more momentum if the kinetic energy is same. This is because momentum is directly proportional to square root of 2m, where K, that is the kinetic energy, is constant. Question number 11. Does the potential energy of a spring decreases or increases when it is compressed or stretched? Answer is, when the spring is compressed or stretched, the mechanical energy is stored in it. Hence, the potential energy increases. Question number 12. Name the process in which momentum changes but kinetic energy does not. Answer is, in the case of uniform circular energy, momentum changes but kinetic energy does not. Question number 13. What happens to potential energy of a bubble when it rises in water? Answer. The potential energy of a bubble decreases when it rises in water. Question number 14. A body is moving at a constant speed over a frictionless surface. What is the work done by the weight of the body? The work done is 0 because it is moving with the constant speed on a frictionless surface. Next question. Question number 15. Define spring constant of a spring. Answer. It is defined as the restoring force set up in a string per unit extension. Next we will take up short answer questions of 2 marks. Question number 16. How much is the work done by a coolie walking on a horizontal platform with a load on his head? Explain the phenomena. Answer. Since the coolie is walking on the horizontal platform with the load of his head, work done is 0 as his displacement along the horizontal direction, and in order to balance the load on his head, he applies a force on it in the upward direction equal to its weight. Thus, the angle between force and displacement is 0, hence work done is 0. Next question. Question number 17. Mountain roads rarely go straight up the slope but wind up gradually. Why? Answer. If the roads go straight up, the angle theta of slope theta will be large. So the frictional force F equals mu into mg cos theta would be less and the vehicles may slip. Also, a greater power would be required. Question number 18. A truck and a car are moving with the same kinetic energy on a straight road. Their engines are simultaneously switched off. Which one will stop at a lesser distance? Answer. By work energy theorem, loss in kinetic energy is equal to work done against the force into distance of friction. Therefore, R kinetic energy is equal to mu into mg into cos theta. Kinetic energy is same, that is constant. Mu is a constant. G is also constant. Only m is different. M is more in the case of truck and it is less in the case of car. So, S is inversely proportional to 1 over m. Hence, truck will stop at a lesser distance. Next question. Question number 19. Is it necessary that the work done in the motion of a body over a closed loop is zero for every force in nature? Why? Answer. No, it is not necessary that work done in motion of a body over closed loop is zero for every force in nature, because work done is zero only in the case of conservative forces. Question number 20. How high must a body be lifted to gain an amount of potential energy equal to kinetic energy it has when moving at a speed of 20 meters per second? The value of acceleration due to gravity at a place is 9.8 meters per second square. So, it is given that potential energy is equal to kinetic energy and velocity is 20 meters per second and value of g equals 9.8 meters per second square. Let us solve it. Answer. We know potential energy is mgh equals kinetic energy. That is, kinetic energy is half mv square. Now, we have to find the value of h. Therefore, h is equal to mv square by 2mgh. M and m gets cancelled. So, h equals v square by 2g. That is equal to v is given as 20 meters per second. V square is 20 into 20 divided by 2 into 9.8. Simplifying, we get the answer of h equals 20.4 meters. Question number 21. Give an example in which a force does the work on a body but fails to change its kinetic energy. Answer. When a body is pulled on a rough horizontal surface with constant velocity, work done is on the body, but kinetic energy remains unchanged. Question number 22. A bob is pulled sideways so that string becomes parallel to the horizontal and released. Length of the pendulum is 2 meters. If due to air resistance, loss of energy is 10%, what is the speed with which the bob arrives at the lowest point? Assume g is equal to 10 meters per second square. Answer. So, it is given 10% of energy is lost due to air resistance. So, half of mv square, that is kinetic energy, is equal to 90% of the potential energy. Potential energy is given by mgh. So, to find the value of speed, that is velocity, v is equal to, rearranging in this equation, m and m gets cancelled, v is equal to 2 into gh, square root of 2 into gh. Putting the values, we get v is equal to 6 meters per second. Next question, number 23. Two springs A and B are identical except that the spring A is harder than spring B. That is, Ka, spring constant of A, Ka is greater than Kb. If these are stretched by the equal force, in which spring will the work be more? By Hooke's law, answer. By Hooke's law, F is equal to K into X, where F is the force and small k is the spring constant and X is the compression or expansion. Therefore, X is equal to F by K. We also know that work done by spring is given by the relation W is equal to half of K x square. So, for the same F, work done by spring A, WA is equal to half of Ka into x square. But substituting for x is equal to F by K, we get work done by A is equal to half of F square by Ka square, Ka. Similarly, for spring B, work done by spring B, WB is equal to half of F square by Kb. Let it be equation 2. So, dividing equation 1 by equation 2, we get WA by WB is equal to KB divided by KA. As KA is greater than KB, that is given in the problem, so WA will be less than WB. Question number 24. Find the work done if the particle moves from position R1 is equal to 3i plus 2j minus 6k to a new position R2 equals 14i plus 13j minus 9k under the effect of force F is equal to 4i plus j plus 3k. Answer. R, the distance is R2 minus R1. Therefore, subtracting Ri from R2, we get 11i, R is equal to 11i plus 11j minus 3k. That is, you subtract 3i plus 2j minus 6k from 4i plus 14i plus 13j minus 9k. We get the answer for R as R equal to 11i plus 11j minus 3k. Therefore, F is equal to F dot R, that is equal to multiplying with 4i plus j plus 3k. We get Fi is equal to 4i plus j plus 3k into R. Work is W is equal to F dot R. So, therefore, we have to multiply this vector by this vector. So we get 4 into 11, 44 plus 1 into 11, 11 square plus 3 into minus 3, that is minus 9 whole square. So the answer as we get 46J. Next, next question. Question number 25. Springs A and B are identical except that A is stiffer than B. That is, the spring constant or force constant Ka is greater than Kb. In which spring is more work spended if they are stretched by the same amount? Here stretched by same amount means X is same for both the springs. Answer. We know the equation for work done in the case of spring is W is equal to half of K into X square, where K is a spring constant, X is the displacement. And this suffix A is to indicate the spring number. So work done by spring A is equal to half of Ka X square, and work done by spring B is equal to half of Kb into X square. Dividing one by the other, Wa by Wb is equal to half of Ka X square divided by half of Kb X square. So this half of gets cancelled. It is Ka by Kb. X square by X square also gets cancelled because for the it is given that X is same for both the springs. Therefore, Ka it is also given that Ka is greater than Kb. Therefore, Wa will be greater than Wb. That is the answer. Next question. A ball at rest is dropped from a height of 12 meters. It loses 25% of its kinetic energy in striking the ground. Find the height to which it bounces. How do you account for the loss in kinetic energy? Answer. If the ball bounces to a height h dash, then mgh dash is equal to 75% of the mgh. It is given 75% of the kinetic energy, 25% of kinetic energy is lost. So therefore mgh dash is equal to 75% of the mgh. Therefore h dash is equal to m and g are same for both. So it gets cancelled and it is 0.75 h. That is equal to 0.75 into 12. So the value of h dash is 9 meters. Which of the two units, that is kilowatt hour or electron volt, is bigger unit of energy and by what factor? Kilowatt hour is bigger unit because 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules, whereas 1 electron volt is 1.6 into 10 to the power of minus 19 joules. So simplifying the right hand side, we get the answer as 2.25 into 10 to the power of 25. So kilowatt hour is greater by 2.25 into 10 to the power of 25. Question number 28. A spring of force constant K is cut into two equal pieces. Calculate force constant of each part. Force constant of each half becomes twice the force constant of original spring. That is, the force constant of each spring will be 2K. We will take up questions of 3 marks. A car of mass 2000 kg is lifted up a distance of 30 meters by a crane in 1 minute. A second crane does the same job in 2 minutes. Do the cranes consume same or different amounts of fuel? What is the power supplied by each crane? Neglect the power dissipation against friction. Answer given. T1 is equal to 1 minute, that is 60 seconds, and T2 is equal to 2 minutes equals to 120 seconds. Therefore, work done is equal to F into S, that is equal to F is M into G. Therefore, work done W is equal to MGS, that is equal to 5.88 into 10 to the power of 5 joules. As both cranes do the same amount of work, so both consume same amount of fuel. Therefore, power P1 is equal to W by T1 and power P2 by the second crane is equal to W by T2. Therefore, P1 will be is equal to, putting the values, 9800 watts and P2 will be equal to 4900 watts. Question number 30. A ball bounces to 80% of its original height. Calculate the mechanical energy lost in each bounce. Therefore, let initial potential energy be mgh. Therefore, potential energy after first bounce is equal to 80% of h. That is mg into 80% of h. That is equal to 0.80 mgh. Potential energy lost in each bounce is equal to 0.2 mgh. Therefore, fraction of potential energy lost in each bounce is equal to 0.2 mgh divided by mgh. Therefore, that is equal to 0.20. We will continue answering 3 marks questions. Question number 31. 20 joules of work is required to stretch a spring through 0.1 meter. Find the force constant of the spring if the spring is further stretched through 0.1 meter. Calculate the work done. Here, work is given and initial string stretch x1 is given as 0.1 meter. We are required to find the force constant, that is spring constant, small k, if the string is further stretched, that is initially it was 0.1 and it is further stretched by another 0.1. Calculate the work done. Let us answer the question. So you write down the given quantities. The potential energy of the spring when stretched through a distance 0.1 meter is given by work done U is equal to half of k into x1 square. Here the value of U is 20 joules. We have to find the value of small k and value of x1 is given as 0.1 meter. Let us substitute. Therefore, 20 is equal to half into k into 0.1 whole square. Therefore, everything is known except k. We will simplify and find the value of k. K is equal to 20 into 2, 40 divided by 0.1 into 0.1. Therefore, becomes value of k is 4000 newtons per meter. Now we have to go to the calculate the second part of the question to calculate the work done. So, when the spring is further stretched through 0.1 meter, then potential energy will be given by the relationship U dash is equal to half of small k into x1 plus x2 whole square. In this equation, U dash we have to find out. The value of k we have calculated in the previous step and x1 is 0.1 and x2 is also 0.1. We will substitute the values and we get U dash is equal to half into 4000 into 0.1 plus 0.1, that is equal to 0.2 whole square, that is 80 joules. And now the difference additional work required is, so U dash is 80 joules minus the original given as the original work done was 20. So therefore 80 minus 20, that is equal to 60 joules of work done is done to stretch the spring further. Question number 32. A pump on the ground floor of a building can pump water to fill up a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meters above the ground, how much electric power is consumed by the pump? The efficiency of the pump is 30%. You please read the question again and note down the given quantities. The given quantities are volume equal 30 meter cube, and that is T, small t is 15 minutes. And if the tank is, and height of the tank H is equal to 40 meters. So we have to find the power of the pump. The power is, and the efficiency of the pump is given as 30%. Let us answer the question quickly. 30% of the power is equal to P1 equals W, that is work done or potential energy, divided by T1. So P1 becomes, P1 is equal to, we know that it is M into G into H. M is the mass, G is the gravitational force, and H is the height of the tank, and time is the time taken to fill up. That is equal to, now we have, that is equal to V into rho, that is volume, mass into volume is given by the density into volume, GH divided by T, where rho is the density of water. Therefore, 30% of the power is given by the relation. We can substitute 30 over 100 into P. Power equals V volume, rho density, G is the gravitational force, H is the height, and T is the timing. That is equal to 30 into 1 into 9.8. G, value of G is 9.8. Here the density of water is 1 into 40, and this 30 is volume, divided by 15 minutes. 15 minutes have to be converted into second. Therefore, to convert it into seconds, we multiply 15 into 60. Therefore, it is simplifying, we get the power as 43.6 kilowatt. Next question. We will continue with answering numerical problems. A body is moving along z axis of a coordinate system under the effect of a constant force, given as F is equal to 2I plus 3J plus K. Here please note that I, J, K are unit vectors in X, Y and Z axis. Find the work done by the force in moving the body through a distance of 2 meters along Z axis. So we have to find the work done. Please note here work done is along the Z axis because the body is moving along the Z axis. Let us answer the question given. Write down the values of F is equal to 2I plus 3J plus 3K, and S is equal to 2K. That is, the distance is 2K along Z axis. Therefore, S is 2K. I, J, K are unit vectors in X, Y and Z axis respectively. Therefore, work done is given by, we know, F into S. So, we have to multiply F 2I plus 3J plus K into 2K. So, we get the answer as 2 joules. That is 2I that I is 2I is because the coefficient of 2I into I is 0 here in this vector. I is 0, J is 0. Therefore, it becomes K into K. Therefore, that becomes 2 joules. The remaining factors with I and J become 0. Question number 34. Water pump is pumped out of a well 10 meters deep by means of a pump rated 10 kilowatt. Find the efficiency of the motor if 4000 kgs, 4200 kg of water is pumped out every minute. Take G is equal to 10 meters per second square. We will find the answer. Answer. Input power is given by as input power is equal to 10 kilowatt. It is given. Therefore, output power is work done divided by time taken. That is equal to work done is equal to potential energy mgh divided by T. Therefore, substituting the values, m is 4200 kg and gravitational force is 10 meters per second square and height is 10 meters divided by minutes. It is 60 minutes per minute, every minute. So 1 minute is given and seconds we have to convert divided by 60. So that is the value is 7 kilowatt. Therefore, efficiency, we know by definition, it is output by input. Input is given as 10 kilowatt, output we have calculated as 7 kilowatt into 100. Therefore, substituting 7 by 10 into 100. So, efficiency is 70%. Question number 35. In lifting a 10 kg weight to a height of 20 meters, 230 joules energy is spent. Calculate the acceleration with which it was raised. So answer. Work done is equal to mgh plus m into ah. And simplifying, we get m taking m as constant. That becomes work done is equal to m into g plus a into h. Therefore, W is given as 230 joules. Energy equals mass is 10 kg and into height is 2 meters. Height is 2 meters into 10 kg plus acceleration A. We do not know the value of A. We have to find the acceleration in which it was raised. Therefore, simplifying, we get 230 divided by 20 minus 10. So, the value of acceleration is 1.5 meters per second square. Next question. Question number 36. A railway carriage of mass 9000 kg moving with a speed of 36 kilometers per hour collides with a stationary carriage of same mass. After the collision, the carriages get coupled and move together. What is their common speed after collision? What is the type of this collision? Please analyze the question. First, M1, that is mass, the first carriage is moving, whose weight is 9000 kg, is moving with a speed of 36 kilometers per hour, and the second carriage is stationary, that is which is not moving, and after it collides and moves with the same velocity coupled together. So we have to find the velocity after collision and we have to identify the type of collision. So M1 is given is M1 is equal to 9000 kgs and initial velocity U1 is 36, velocity of the first carriage is 36 kilometers per hour. That is equal to kilometers. It is given in kilometers. We have to convert into meters per second. To convert kilometers into meters, you multiply with 1000. So that becomes 36,000 divided by per hour. 1 hour we have to convert into second. 1 hour is equal to 60 minutes into 60 seconds. So that value becomes U1 is equal to 10 meters per second. This you remember how to convert the units from kilometer to meter and hour to second. Next step. The second wagon, which is stationary, M2, it is also equal weight, 9000 kgs, because it is same mass. Therefore, the velocity, initial velocity of m2, which is stationary, u2 equal to 0. We have to find velocity v1 which is equal to v2 equals what? Because the both after collision they are moving with the same velocity v, where v1 is the velocity of first carriage and v2 is the velocity of the second carriage. So by conservation of momentum, we will write the equation m1 u1 plus m2 v2 is equal to m1 plus m2 into v, where m1 is the mass of first carriage, m2 is the mass of second carriage, u1 is the velocity of first carriage, u2 is the velocity of second carriage before collision, and v is the velocity after collision. Therefore, by substituting these values, we know m1 u1, m2 u2 equals m1 plus m2 into v. So put the values and we find that velocity is 5 meters per second. Therefore, the total kinetic energy before collision is half of m1 u1 square plus half of m2 u2 square. Therefore, m2 u2 is 0, second term becomes 0. Therefore, it is half of 9000 into 10 into 10. So that is equal to 450,000 joules. And after collision, the total kinetic energy after collision is equal to half of m1 plus m2 into v square. Therefore, it becomes half of m1 is 9000, m2 is 9000, v we have calculated as 5 meters per second. Multiplying, substituting the values and multiplying, we get the kinetic energy after collision is 225,000 joules. So definitely the kinetic energy after collision, that is 225,000 joules, is less than 450,000 joules. Hence, collision is inelastic because kinetic energy has changed after collision. Therefore, the collision is inelastic. We will continue with the next question, number 37. A bullet of mass 0.02 kg is moving with a speed of 10 meters per second. It can penetrate 10 centimeters of a wooden block and comes to rest. If the thickness of the target is reduced to 6 centimeters, find the kinetic energy of the bullet when it comes out. Because the thickness is reduced, the bullet comes out instead of coming to rest. Let us answer it. So let the x1 initial thickness be 10 centimeters, that is equal to 0.1 meters. So penetrating this work done in first case is F into x1 is equal to half m v1 square. That is work done is equal to kinetic energy on the right hand side. Therefore, Fx1 is equal to putting the value of mass as 0.02 kg and v as 10 meters per second and divided by 2. So that is equal to 1 joule. So work done is 1 joule. Now we will calculate the force. Therefore, force is given by m v1 square by 2 into x1. We already know the value of m into v1 square divided by 2 as 1 joule. 1 joule by x1. Therefore, force is work done by displacement, that is equal to 1 divided by 0.1 meters that we have found in first equation, that is equal to 10 newtons. So therefore force is 10 newtons. In the second case, x2 is equal to 6 centimeters, that is 0.06 meters. Therefore, Fx2 is equal to half into m v1 square minus half into m v2 square. That is Fx2 is equal to initial kinetic energy minus final kinetic energy. From this we can find out the value of final kinetic energy by rearranging this equation. Therefore, final kinetic energy is equal to half into mv1 square minus the term on the left hand side, that is half mv1 square minus fx2. Let it be equation 2. Therefore, we know already half into m into v1 square is 1 joule. That is we have calculated in equation 1. 1 joule minus F here we have found as 10 newtons. So 10 into x2 is 0.06 meters. So simplifying, we get the value as final kinetic energy is equal to 0.4 joules. Next question. Question number 38. A man pulls a lawn roller through a distance of 20 meters with a force of 20 kg weight. If he applies the force at an angle of 60 degrees with respect to ground, calculate the power developed if it takes 1 minute in doing so. Please note down the given values separately and write down in your notebook. So answer. We know power is equal to work done by time taken. Therefore, work done is F into force into distance into the angle cos of theta, where theta is the angle with respect to ground. F is given, S is given, cos of 60 degrees we have to write, and T also we have to write in seconds. Substituting these values, F is 20 into 10. That is F is equal to mass into gravitational force. 20 into 10 into S is 20 meters into cos 60 divided by 60 seconds. That is equal to 32.66 watts. Question number 39. Two identical blocks of weight 5 kg are moving with the same speed of 2 meters per second towards each other along a frictionless horizontal surface. The two blocks collide, stick together and come to rest. Consider the two blocks as a system. Calculate the work done by external forces and internal forces. Answer. Here, no external forces are acting on the system because the friction, it is frictionless. Therefore, F external equal to 0 and work done by external force is also 0. According to work energy theorem, the total work done is equal to change in kinetic energy. Therefore, the total work done is W external plus W internal is equal to final kinetic energy minus initial kinetic energy. This you have to remember. The change in final kinetic energy is final kinetic energy minus initial kinetic energy. So, external force is 0 plus work done internal equals 0, that final kinetic energy because it comes to rest, minus initial kinetic energy is half mu square, where u is the initial speed plus mu square and final initial speed, and because block is moving as a system, hence mu plus half mu square. Therefore, internal energy, work energy is equal to minus mu square. That is half plus half becomes 1. So, minus mu square, that is equal to minus 20 joules. That is the answer. Question number 40. A truck of mass 1000 kg accelerates uniformly from rest to a velocity of 15 meters per second in 5 seconds. Calculate number 1, its acceleration. Number 2, its gain in kinetic energy. Number 3, average power of the engine during the speed, and neglect the friction. So it is given the mass of the truck as 1000 kgs and it is moving with a uniform velocity. It is accelerated uniformly from rest to a velocity of 15 meters per second and in 15 meters per second in 5 seconds. That is, the acceleration is 15 meters per second divided by 5 seconds. We have to find three quantities. First quantity is acceleration. Next we have to find the gain in kinetic energy, and finally we have to find the average power of the engine. And it is also hinted that we have to neglect the friction. Let us answer it. We know that acceleration is given by a is equal to v minus u by t, where a is the acceleration, v is the final velocity, u is the initial velocity divided by time taken. So it is v minus u is 15 divided by 5. So it is 3 meters per second. That is the part 1. Part 2 is kinetic energy is half of m into v square minus u square. Putting the values, half of, that is m is 1000 kg given, divided by 2 into v square is 5 into 5, that is 15, sorry, it is 15 into 15 v square, u is 0. Hence, the value becomes gain in kinetic energy is 1.125 into 10 to the power of 5 joules. So, power is given by power is equal to W by T, that is work done over time taken. That is equal to power is equal to 1.125 into 10 to the power of 5. The work done we have calculated as kinetic energy in the previous step. Divided by time is 5 seconds. We get the answer as 22,500 watts. Question number 40. A body of mass 0.3 kg is taken up an inclined plane to a length of 10 meters and height 5 meters and then allowed to slide down to bottom again. The coefficient of friction between the body and the plane is 0.15. So we have to find the work done by the gravitational force over the round the trip, work done by the applied force over the upward journey, work done by the frictional force over the round trip, and part 4 is kinetic energy of the body at the end of the trip. How is the answer to question number part 4 is related to three answers. This is the question. So please refer to the diagram. It is shown up and down. So here the length of the plane is 10 meters and height is 5 meters and the body is moving. Angle is theta and the forces, applied force is capital F and frictional force is Fk, that is moving along the surface Fk, and the vertical and horizontal components are mg sin theta, mg cos theta, and the downward force is mg, and we have to find the angle theta. So sin theta is equal to Cb, that is vertical, by hypotenuse. Therefore Cb by Ca, that is equal to 10. Cb is 5 and Ca is 10. Therefore it is sin theta is 0.5 and we are taking the finding the value of theta, it is 30 degrees. So the details are given. W answer, work done is equal to Fs, that is equal to minus of mg sin theta into h. Therefore it is equal to, substituting the values, we get minus 14.7 joules is the work done by the gravitational force in moving the body up the inclined plane. So in the downward plane, it is W dash is equal to Fs is equal to plus mg into sine theta plus into h, that is equal to 14.7 joules is work done by the gravitational force in moving the body down the plane, down the inclined plane. Therefore, total work done is W plus W dash, that is equal to 0. Total work done is, this is plus, W is minus and W dash is minus, plus. Therefore, the total work done is 0. Part 2. Force needed to move the body up the plane is given by the relation F is equal to mg sine theta plus frictional force, that is F of k. Therefore, mg sine theta plus mu k into r. So here mu k is the coefficient of kinetic friction and r is the resultant force. Therefore, that is equal to mg sine theta plus mu k into mg into cos theta. The R is known as the reaction. So therefore, WD is the force over the upward journey is given by W2 is equal to F into L, that is equal to mg into sin theta plus mu k into cos theta into L. So substituting the values, we get 18. W2 is equal to 18.5 joules. Part 3. The work done by the frictional force over round the trip is W3 is equal to minus Fk, that is opposite of the kinetic friction force, plus L. L is the length of upwards and another L is for downwards. So therefore it becomes L plus L, that is equal to minus 2 into Fk into L. Substituting the values, that is equal to minus 2 into mu k mg cos theta into L. Substituting the values, we get the answer as 7.6 joules. You please substitute the values and work out yourself. Question number 4. Kinetic energy of the body at the end of the trip. That is equal to the work done by net force in moving the body down the inclined plane. That is equal to mg sin theta minus mu k, that is coefficient of kinetic friction, into m into g into cos theta. Therefore, that is equal to 10.9 joules. Next question, question number 41. An elevator which can carry a maximum load of 1800 kgs, that is elevator plus passenger, is moving up with a constant speed of 2 meters per second. The frictional force opposing the motion is 4000 newtons. Determine the minimum power delivered by the motor to the elevator in watts as well as in horsepower. So this is an elevator problem where which can carry a maximum load of 1800 kgs and it is moving with a constant speed of, that is V is 2 meters per second. The frictional force F is frictional force Fk is given as 4000 newtons. Determine the minimum power delivered by the motor, that is a motor working for an elevator, in watts as well as in horsepower. So downward force of the elevator is F is equal to mg, which is due to mass and the gravity, plus F, that is the frictional force, that is equal to m into g. First put m as 1800 kgs into 10 plus F, that is the frictional force is 4000. The answer is 22,000 newtons. So therefore the power supplied by the motor to balance this force is given by power is equal to P is equal to F into velocity. That is equal to 22,000 newtons into velocity is 2 meters per second. Answer is P is equal to 44,000 watts. So in terms of horsepower, so to convert watts into horsepower, we have to divide by the factor 746. Therefore, it is 44,000 divided by 746. That is equal to 59 horsepower HP. For question number 42, to simulate car accidents, auto manufacturers study the collision of moving cars with mounted springs of different constant. Consider a typical simulation with a car of mass 1000 kgs moving with a speed of 18 kilometers per hour on a smooth road and colliding with a horizontally mounted springs of spring constant 6.25 into 10 to the power of minus 3 newtons per meter. What is the maximum compression of the spring? So please note down all the given quantities as mass is equal to 1000 kgs, velocity is 18 kilometers per hour, and spring constant is 6.25 into 10 to the power of minus 3 newtons per meter. Let us answer the question. At maximum compression, the kinetic energy of the car is converted into the potential energy of the spring. Please note it very carefully. Therefore, kinetic energy is half into K into xm square, that is equal to half into mv square, that is kinetic energy. So right hand side is kinetic energy, left hand side is the potential energy. Therefore, xm is equal to square root of m by k into v. So putting the values, we get the answer as xm is equal to 2 meters. That is the maximum compression. Next question is, give an expression for kinetic energy of a body of mass m moving with a velocity v by calculus method. So this is a repeat video. We have explained it in detail in section 6.3. Please refer our video 6.3 and the details are given here. I will not read once again. Here the details are given. Already explained. You can quickly go through it. State and prove work energy theorem. The statement and proof of work energy theorem has been previously covered in under section 6.2 titled Notions of Work and Kinetic Energy, as well as section 6.6 titled Work Energy Theorem for Variable Forces. In section 6.2, we have explained it using Newton's laws of motion, whereas in section 6.6, we have solved this question in calculus method. So you please note down all the important points given below. The explanations and details of each of the parameter used here are the standard notations. So the insert box explains the calculus part of it. You please note down both and use it whichever is applicable. Question number 45. An elastic spring is compressed by an amount x. Show that its potential energy is half k into x square, where k is the spring constant. Answer. The theory part of this question is explained in detail in section number 6.9 of our previous video. The link for this video is given below in the description part of this YouTube lesson. Hence, you please go back to it, listen all the steps and note down the steps given below. I am not going to explain it again so that the length of video is adjusted within 1 hour. Question number 46. Prove that two bodies of identical masses exchange their velocities after head-on elastic collision. Please note head-on elastic collision. So this is a one-dimensional analysis. This question is explained in detail in our previous video of section 6.11. The link for this video is given in the description part below. Please go through this video, section 6.11, and note down all these steps. The steps are repeated here once again. U1 and U2 are the initial velocities before collision for mass M1 and M2, whereas V1 and V2 are the velocities after collision for the same masses. These M2 is at rest, hence U2 is 0, whereas M1 is moving with velocity U1 before collision. So these steps note down in detail and I am not going to explain it once again. In the last step, please see that we have just proved that V1 becomes V1 equal to 0 and V2 is equal to U1. That means the velocities have exchanged their velocities. The bodies M1 and M2 have exchanged their velocities after head-on collision. Next question number 47. Define elastic and inelastic collision. Answer. The theory part of elastic and inelastic collision is explained in detail in our previous video number section 6.12 on collisions. The link for this video is given in the description part below. Please click the link and write the explanation. However, for your convenience, these definitions are repeated below. Question number 48. A moving body of mass M1 strikes another body B which is at rest and of mass M2. Prove that the fraction of initial kinetic energy of the mass M transferred to the body is 4m1 m2 divided by m1 plus m2 whole square in an elastic collision. Please note m1 is the mass of body A and m2 is the mass of body B which is at rest. B is at rest. So the energy transferred to the body B is we have to prove 4m1 m2 divided by m1 plus m2 whole square in an elastic collision. This question has been answered in section 6.12.2 of collision in the form of question number 12, that is worked example. This example was on nuclear reaction. Please go through it and answer the question. Please note you have to answer and explain all the notations used in this answer part of our question. Hence, it is proved that in the last step for M1, FB, the transferred energy is 4M1 M2 divided by M1 plus M2. Next question, question number 49. Show that in an elastic one-dimensional collision, the relative velocity of approach before collision is equal to the relative velocity of separation after collision. This question and the theory behind it is already explained in our video section 6.12.1 explaining the coefficient of restitution. Please go through it. The link for this video, the previous video, is given in the description part given below. I will repeat the steps for your convenience in the text form. Please note down carefully the notations for initial velocities before collision and after collision, final velocities after collision are as the standard notations. Hence, use law of conservation of momentum and conservation of kinetic energy to answer the question. With this, we conclude our discussions on work, energy, and power. Next, we will take up a new chapter number 7. Till then, goodbye.